Okay, paper 2. So with this one, what I've done is from the high frequency topics again of what we expect. Remember, this isn't the full list, okay? And the full list was on the other video. So the pink questions are the ones that came up. Obviously, more than this came up. However, they are lower frequency. And then what I've done is anything that didn't come up, I've now put in the predicted 2HR topics. Please remember that, for example, indices 167%, like that is more likely to come up again, you know. This isn't a guaranteed list. This is literally just a prediction. You know, we haven't seen the circle theorems yet at all. It didn't come up in paper 1. I do think there is a high chance it's going to come up in paper 2. Okay, percentages increase, decrease. What I mean by that is more like the reverse percentages, or when you're giving a percentage of amount. Okay, so make sure, you know, something we haven't seen, speed, distance, time. That's come up every year. I'm predicting it's going to come up again. However, none of this is guaranteed. And this is just, you know, I would suggest focusing on this for revision, making sure you understand that, and maybe going over what you've done before. Okay, so it's just a bit of help for you and some extra resources. So I'm going to go through the paper. Again, orange, only do this if you're really aiming for those grade 8, 9s, and then greens, try and get that for your grade 6 and 7s, okay? Okay, again, formula sheet, you have this. Please make sure you're utilising this. We have not seen volume or surface area of spheres, cones, cylinders yet, so I definitely think that that will be coming up. Arithmetic sequences, especially as grade 9 students, if you're doing that, we haven't seen that yet, so remember the formula is here. Okay, Tarek buys a laptop. He gets discount of 5% of the normal price. He pays $551 for the laptop. Work out the normal price. So this is a typical reverse percentage here. Now, we can look at this visually. What we're saying, we're going to do two things. We're going to do the multiply method and the visual method, okay? Visually, what do we know? If there is a 5% discount, well, what's 100% minus 5%? This is actually 95%. So we are saying that £551 is 95%. That is what we're saying here. And what we want to work out is 100%. So we could, to find out 1%, and then we can try and find 100%. To find 1%, we divide by 95, and then to find 100, we multiply by 100. So we're going to do the same on this side. We're going to divide by 95, and then multiply by 100. So in your calculator, you're literally going to put 551 divided by 95, because that gives you 1%, then times it by 100 to get 100%, we get 580. So we know this is £580 originally. And this makes sense because originally it should be more expensive, right, if we've got the 5% discount. The other way we could do this question is using the multiplier method, where you say to yourself, we don't know how much the original is. When we multiply that by a decrease of 90% using the multiplier, a decrease of 5% is 95% of a number. As a multiplier, as a decimal, that is 0.95. And we know that that equals 551. So how are we going to find the original one? I'm going to divide both sides by 0.95. So 551 divided by 0.95. And you'll see that's exactly the same as what we have done. So 551 divided by 0.95, and it's going to give you 580. Again, two different ways, same principle. It just depends on what you find easier and how you access this information. Okay, part B. Joanne invests $6,000 into a savings account. The savings account pays compound interest at a rate of, okay, now I know there's been a compound interest one, however, this is good. When we're talking about interest, we're an increase, right? We increase by 2.4%. Percent is out of 100, so if it's an increase, we add that to 100, we get 102.4%. Okay, and then 101.7%.
What did you multiply that with?
I didn't multiply, I added 100% to each one because we're doing an increase, so 100% plus, right? Then the multiplier. What is my multiplier here? I need a decimal. How do I turn a percentage to a decimal? I divide by 100. So my multiplier is 1.024, and my multiplier here is 1.017. So 6,000 multiplied by, for the first year it's 2.4, so that's 0.24 to the power of 1, because it's 1 year, but we don't technically need to write to the power of 1. Then, for each extra year, it's 1.017. If they put it in for a total of 3 years, how many years are left? So I've already got the first year, well done, 2 years left, okay? So my calculator, 6,000 times 1.024 to the power of 1, but you don't have to put to the power of 1 because anything to the power of 1 is just that number, and then to the power of 2. So this is going to give me 6354.6716. However, it's not told us to round to anything, but what do we know for sure? If we're dealing with money, if it doesn't tell us what to round, what would be the biggest thing we would round to? It'd be 2 decimal places, wouldn't it? Okay, so 6,354.67. Okay, so you need to use your head a bit there. Okay, Andy cycles a distance of 30 kilometres at an average speed of 24 kilometres per hour. He then runs a distance of 12 kilometres at an average speed of 8 kilometres per hour. Work out the total time. Give your answers in hours and minutes. So the first thing that I realise is that this is a speed distance time question. Yeah, we are not given the formula for speed distance time. You need to know this formula. And what is it? Speed equals distance divided by time. And if we want to know the total, we've got to work stuff out. So what do we have so far? Andy cycles a distance of 30 kilometres. Is that a speed, a distance, or a time? It's a distance. It even says he cycles a distance of. Yeah? At an average speed. So what do I have here? A speed, a distance, or a time? A speed. Okay, so I've got a speed and a distance. What is missing? The time. Okay, so I can start by doing that. So if we just look at the cycling, okay, I know that speed equals distance over time. I'm missing the time. Okay, so distance times speed is not going to give me. Okay, it's distance divided by speed. Okay, remember, if we're going to multiply both sides by time and then divide both sides, yeah? So, time equals distance over speed. Okay, so our time is 30 divided by 24. 30 divided by 24 into your calculator is 1.25. Remember, this is in hours, isn't it? Okay, we'll come back to that in a second. Then he runs. Now, again, with the running, what do we have? We have a distance and we have a speed. So the same again, we want to work out the time. So distance over speed. Time is 12 divided by 8. So 12 divided by 8, I get 3 over 2, which is 1.5 hours. Okay, lovely. So what does it want? The total hours in minutes. So if I add them together, I get 2.75 hours. Does that mean that's 2 hours and 75 minutes? No. For sure it's 2 hours, but 0.75 is what? Is 3/4. 3/4 of an hour, we actually know, is 45 minutes. However, what if we didn't know that 3/4 of an hour is 45 minutes? I could multiply my 0.75 by 60, because 60 minutes, and this would tell us what the minutes are. Okay, so watch out for that. You don't want to get stuck. 2.75 is probably the most common wrong answer here. All right. Okay, question 3. So this is a bit more of a problem solving one. So the length of each side of a square. First of all, what do we know about squares? Yeah, all the sides are equal, okay? Make sure they always give you clues in these questions, right? And it's 4 centimetres greater than the length of each side of square A. Okay, well, imagine if I call one of the sides x. If this is 4 greater, this is going to be x plus 4, because it's 4 more, right, than that length. The area of square B is 70 centimetres greater than the area of square A. So what is the area of square A? Area of A is base times height, x times x, which is x squared. Okay? That's what we know. You always work out what you know. What's the area of B? X plus 4 is our base times x plus 4, which is our height. Absolutely. So if I expand this, x squared plus 4x plus 4x plus 16, I'm going to get x squared plus 8x plus 16. So this is my area for B. Now, this is the part that's interesting, is reading the question to understand what is going on. So here we go. We'll read it again. We've worked out the area of each, we know the length of each. The area of square B is 70 centimetres squared greater than the area of square A. So that is saying that the square B is 70 bigger than A. Okay? So that means the area of A plus 70 must equal the area of B. Do we agree or disagree? Yeah. So I can now simplify this. Now what I find is that if I have, I can minus x squared from both sides. That's going to cancel, isn't it? Okay. And then going to minus 16 from both sides. So 70 minus 16, I get 54 equals 8x. How am I going to get x? Divide both sides by 8. And then I get 27 over 4 equals x. Okay, so x equals 6.75 exactly, actually. And it wants the answer to 3 significant figures. Oh, no, sorry. What have we done? I've gone and found x and thought I finished the question. But what do we need to always double check? They never always want x, do they? No? If we read the question, it says, find the area of square B. Okay, do I have x? Right, what is the area of square B? So, I can substitute it into here, or I can just put it in here. So, let's see. So, our square is x plus 4. So, this is 10.75 plus, and 10.75, because plus 4 is 10.75. So, 10.75 times 10.75 is going to give me 115.5625. But what do I want? 3 significant figures. So this is actually going to be 1, 2, 3. I look at the number there next to it. This is 116 centimetres squared. Now, if I had a bit of a time in the exam, I could actually see, am I even right? Who even knows? What do we know? Well, if we know that x is 6.75, let's just work out for fun the area of A. 6.75 squared, or times 6.75, and I get 45.56, etc., right? If I add 70 to that, am I going to get roughly 115? And I am. So I know that I'm right. You can walk out of that exam with a guaranteed 4 marks. Okay, and remember, those of you who are aiming to get the grade 6 on the higher paper, you don't need to answer half the questions at the end. You just need to get method marks. So you can spend your time guaranteeing those marks. It's all right. There are only red sweets and yellow sweets in a bag. There are n red sweets in the bag. There are 8 yellow sweets in the bag. Okay. If there are n red sweets, that means we do not know how many red sweets we have. Okay, so it could be a little, it could be a lot. What do we know for a fact is that for sure we have 8 yellow sweets. That is what we know. Okay, remember n, it could be any number. It could be 1. Okay, it could be a million. Right, the question says, Sajid is going to take at random a sweet from the bag and eat it. He says the probability that the sweet will be red is 7 out of 10. Right? So he's saying 7 out of 10 is going to be red. 7 out of 10 is the same as saying 14 out of what? 20. Perfect. What's this the same as saying? 21 over 30. Great. What's this the same as saying? 28 over 40. What's this the same as saying? 35 over 50. Now, if the probability is this, if you think about it, if the probability of getting red is 7 out of 10, what does that mean? How many yellows do we have? We have 3 yellow. Is that true? Do we have 3 yellow? No. How many do we have? 8, and that is a fact. Okay, well, what if it was 14 out of 20? How many yellows does that give me? 6. Do we have 6 yellow? No. Okay, how about 21 and 30? How many yellows does that give me? 9. Does that give me 8 yellows? No. How about 28 to 40? 12? Is that 8 yellows? No. 35 to 50? 15. Is that? What we notice now is no matter what we change our probability to, the equivalent fractions, we're going to find, are we ever going to be able to get 8 yellow sweets? No. Okay. Or, so we will never, because now it's going to keep increasing, isn't it? You can see it's increasing 3 to 6 to 9 to 12 to 15. And there are exactly 8 yellow sweets. So we will never have exactly 8 yellow sweets. Okay? I would say that was nice and easy 3 marks for a bit of common sense. Okay, next one. So after Sajid has taken the first sweet from the bag and eaten it, he's going to take a random second sweet from the bag. Given that the probability that both the sweets he takes will be red is 3 over 5, work out the number of red sweets in the bag. Okay. So, red sweets in the bag. How many red sweets are there? There are n. Out of the total sweets. Now, the total sweets is red plus yellow, right? How many red are there? N. Plus, how many yellow? 8. Okay, so this is the probability of taking 1 red sweet. The amount of red out of the total. We've done probability before with numbers, but with algebra, you've just got to think a little bit abstract. Now, we need to multiply that by the probability. Imagine I've eaten a red sweet. If I've eaten a red sweet, what's the probability of picking the red the second time? Is there going to be n red sweets if I've already eaten one? No, there's going to be n minus 1 because I've eaten a red sweet. And then is my total going to be n plus 8? No, it's going to be n minus 1 plus 8. What's n minus 1 plus 8? N plus 7. So they're saying that this equals 3 over 5. Now, this is a bit of a challenging question. However, it's about getting these marks. Even if you was to write this down here, you're going to get a mark. Okay? You're going to get a mark for that. And you need to be able to start thinking, okay, what do you do when you don't know what to do? It is 5 marks here. Okay, so they're throwing out all sorts of methods and marks. Now, once you get to something like this, probability of red, you might have something here, you might have something different here. But if you're multiplying them and you're getting 3/5, you're probably going to get a mark as well. Do you see? Then, how do we multiply fractions? The numerator multiplied by the denominator. Okay, and this equals 3/5. Right. Now you see brackets. What are you going to do? Expand them. So on my numerator, n times n squared, n times -1, minus n, over my denominator, n times n squared, n times 7, 7n, 8 times n, 8n, 8 times 7, 56. What does this equal? 3/5. Okay? So we're doing all of these steps. These problem-solving questions have a lot of mixed skills in, and this is what we need to work on. Now, what do we do? So, we can tidy this up because on the denominator here, we're going to get 15n, aren't we? Right, so we have n squared minus n over n squared plus 15n plus 56 equals 3/5. Okay, to make my life easier, I'm going to do what's called a cross multiplying. I'm going to multiply both sides by 5 to get rid of this denominator. And I'm going to multiply both sides by this quadratic to get rid of that denominator. So what it's actually going to look like, and some of you may have seen that before from your teachers, we're going to get 5 lots of the n squared minus n equals 3 lots of the n squared plus 15n plus 56. Okay, so this is where we're at now. So now what do you think I need to do? Expand again. So 5n squared minus 5n equals 3n squared plus 45n, 3 times 56, plus 150, 168. Okay. Now, the next thing I'm going to do is rearrange this to get 0 so that I can solve this quadratic. I'm actually going to minus everything from my right-hand side and bring it over to the left. So 5n squared minus 3n squared is 2n squared. Minus 5n minus 45n is minus 50n. And then minus 168. Now, this equals 0. They're all in the 2 times table. So if I wanted to, I could divide everything by 2 to make my life easier. So n squared minus 25n minus 84 equals 0. Do you know 2 numbers that multiply to give you negative 84 and add to give you negative 25? Anyone? No? Okay, so then you're going to use the quadratic formula, or some of you have been using your calculators. Okay? So, 28 and negative 3. So, n minus 28 and n plus 3 equals 0. So you could factorize it. So what do we get? N equals 28 or n equals negative 3. Can we have a negative amount of sweets? No, so we don't really care about the negative one. We have to bring it back into context. We're going to reject that. What we do have is a positive amount, 28 sweets. 28 what though? It's 28 red sweets, so there must have been 28 red sweets. Okay, now in this question, it was 5 marks. It was difficult, okay? However, you can see all the skills in there. We've got expanding, manipulation of algebraic fractions, factorizing, solving quadratics. Okay, this is where these are all rolled into one. So you're using a lot of skills within a probability question. Okay, question 5. Carlo puts tins into small boxes and into large boxes. He puts 6 tins into each small box and 20 tins into each large box. Carlos puts a total of 3,000 tins into the boxes so that the number of tins in the small box and the number of tins in the large box is in the ratio 2 to 3. So the first thing we know is 2 to 3 means there's 5 parts altogether. So I can do 3,000 divided by 5, which gives me 600. Okay? So that means, okay, so now 2 parts is 600 times 2, which is 1,200. And 3 parts is 600 times 3, which is 1,800. Now, you know you're right here because they will add to give you 3,000. Okay? But what has this given me? This has given me the number of tins. This doesn't necessarily tell me, remember, this is tins in the small box and tins in the large box. It doesn't tell me how many boxes. So I'm going to divide this by 6 because there's 6 tins in the small box. So this gives me 200 small boxes. Okay. Then I'm going to divide this one by 20 because we're going to have 90 big boxes. So now what we have to look at is it says, Carlo says that less than 30% of the boxes filled with tins are large boxes. Okay, well, 90 divided by 290, because that is the total. So if we did that into our calculator, 90 divided by 290, this gives me, and then times by 100, 31%. So he says less than 30%. Well, actually, there's 31%. So is he correct? No, as there is. And you remember, write that sentence. If it asks you, is he correct? Well, tell me, is he correct or not? No, as there is more than 30%. Okay. Okay, question 6. So what we're going to do now is we have some equivalent fractions and then we've got to find the ratio. So what we know is that A over B equals 2/5, but B over C equals 3/4. So to find the ratio, I can see that on both sides I have B's in common. However, I can't compare them yet because my B's are not, 5 and 3 are not the same. However, if I find the lowest common multiple of 5 and 3, that is going to give me 15. So I want 15 as my denominator here, and 15 is my numerator here. What if I multiplied my fraction by to get 15? I've multiplied it by 3 over 3. So I'm going to have 6 over 15. And for this fraction, I've multiplied it by 5 over 5. So I'm going to have 20. So that means my A is 6, my B is 15, and my C is 20. So my ratio is 6, 15, 20. Okay, circle theorems. Now, lately, in the past few papers, I've actually seen circle theorems come up, not just on its own anymore. It's come up with area. It's come up with SOHCAHTOA. It's come up with a few different things. So just be aware that sometimes you need to use multiple skills, okay? Now, if it says you must give a reason for each stage of your working, it means you have to write down your reason. So first of all, it wants us to find the angle A, B, D. Now, bearing in mind, circle theorems comes up every year. Every year this comes up, right? So A, B, D means I want this angle here because I start at A, B, D. Okay, so what do I know? For sure, what I know is that this angle here, this blue angle, is 80. How do I know that's 80 degrees? because, okay, so I'm going to put angle DBF equals 80 degrees. And that is because opposite angles in a cyclic quadrilateral add to 180 degrees. And 180 minus 100 is, in fact, 80 degrees. Now, it's really important that you actually write quadrilateral, that you don't just write quad. I've seen people do it, okay? Now, opposite angles, a cyclic quadrilateral is a quadrilateral where all the four corners of the quadrilateral are on the circumference, okay? Please make sure you do that. Now, the next, what else do we know? Okay, alternate segment theorem. Oh, wait there. This 40 degrees equals 40 degrees here. Okay, alternate segment theorem. Okay, so this is CBF equals 40 degrees. Why? And this is because of alternate segment theorem. Okay, so that's another one that we know. Do you remember, guys? It looks like this. It's normally when we have a triangle, and then this angle equals this angle, and this angle equals this angle. So when we have a triangle and a tangent, this is alternate segment theorem. Then lastly, the last thing we know is, what do angles on a straight line add up to? So 180 minus 40 minus 80 equals 60 degrees. But we have to write angles on a straight line, add up to 180 degrees or equals 80 degrees. But the point is that this question is 4 marks. And for 4 marks, you need to show all of your working and write the sentences. Okay, so for this style of question, we haven't seen any shaded regions, inequalities, or straight line graphs. Sometimes they give it to us to do. Now, there are lots of different methods in this. However, the method that I personally advise, okay, is like, when in doubt, work it out, essentially. So here we go. First of all, forget about the inequality signs. We have 2y plus 4 equals x. We have x equals 3 and y equals 6 minus 3x. Okay? Now, which one's the easiest so far? X equals 3. X equals 3 is this line, because anywhere on this line, x will equal 3. Now, 2y plus 4 equals x. If you don't want to rearrange this or figure it out, remember, to draw a straight line, you only need 2 coordinates, okay? And the only coordinates you need are, you can use when x is 0 or when y is 0. If you think this is x, y, this method will never fail you. Coordinates are always x, y, right? So when x is 0, what happens here? I get 2y plus 4 equals 0. So I get 2y equals minus 4. So y equals negative 2. Done. Now, what happens when y is 0? I get 2 lots of 0 plus 4 equals x. So that means 4 equals x. I've done. I've now got these 2 coordinates. So 0 minus 2 and, 0 minus 2 and 4, 0. So I'm now going to plot this line here. Okay, I'm going to use a ruler. There we go. So there is that line done. Now, the last line is y equals 6 minus 3x. Now, if I wanted to, I could say it crosses at 6 and my gradient is negative 3, right? So for every one across, I go down 3. However, if you're still not comfortable with that, remember, you can use coordinates. What happens when x is 0? I get 6. We know that. What happens when y is 0? When y is 0, I get 0 equals 6 minus 3x. So minus 6 equals minus 3x. Divide both sides by minus 3, I get 2 equals x. So then 2. Okay, so now I'm going to plot this line. Okay, so now we've drawn the lines, we need to colour in what we want. So we want to know, when is 2y plus 4 less than x? So this line is our pink line. When is this less than x? Okay. Now, again, you can plug in a number. Okay, so let's try 0, 0. So I always like to plug in 0, 0. So 2 lots of 0 is 0. So is 4 less than 0? 0, 0 is here. Is 4 less than 0? No, that's false. So we don't want above the pink line. We want below it. So this is the area that we would shade. Now I do actually shade the area I don't want, but just to make our life easy, I'm going to do the area we do want. Then x is less than 3. Where is x less than 3? Is it on this side or on this side? Well, we know it's on the left-hand side. So this is all of x is less than 3. And then lastly, where is y less than 6 minus 3x? Again, I'm going to try that 0 point to see if we want it or not. Is 0 less than 6 minus 3? That's saying is 0 less than 3? Yes, so we want everything on this side. So we can clearly see that actually the bit that we want is this region here. I'm just going to go over it in black pen so you can see. This is the region that we want, and you can label it R. Okay, now I know I took a long time with this question. However, this question covered so many skills: plotting straight line graphs, which some of these are sometimes one question on its own. Okay, shading inequalities, understanding them. Awesome. Okay, question 9. Curve C has equation y equals x squared plus 3x minus 3, and the line has equation y minus 5x plus 4 equals 0. Show algebraically. Okay, so we've got to show that that they have exactly one point in common. Okay, so we've got to find where essentially they intersect. So we have simultaneous equations here with a quadratic and a linear. Now, I always like to use substitution. So I'm going to rearrange the second one to get y equals. I'm going to add 5x to both sides and minus 4 to both sides. So here I have y equals 5x minus 4. Now, instead of writing y on this side, I'm going to write this. Why? Because we know that's what y equals. There's a lot of y's in this conversation. So I get 5x minus 4 equals x squared plus 3x minus 3. Now, whenever I have an x squared term and an x and a constant, I am looking for a quadratic. So I want to make this equal to 0 so we can solve it. So I'm going to minus 5x from both sides and add 4. So that's going to give me 0 on this side. If I minus 5x, it only affects the 3x. So 3x minus 5x is minus 2x. Minus 3 plus 4 is minus 1. Okay, this is the same as saying x squared minus 2x minus 1 equals 0. They are the same thing. So now we can factorize or solve in your calculator or use a quadratic formula, whatever's easier for you. So two numbers multiplied to give you negative 1, add to give you minus 2. It's got to be right there. I've gone wrong. This is a positive 1. How did I know I'd gone wrong? Because I don't know two numbers that add multiply to give me minus 1. And actually, minus 3 plus 4 is positive 1. Well done for those of you who spot that mistake. And remember, just take your time. So adds to give me positive 1. Okay, so that's two negative 1s. They multiply to give me positive 1 and add to give me minus 2. So that means x equals 1. Then we have y. Now, I know that y equals 5x minus 4. We've just figured out that x is 1. So 5 minus 4 is also 1. Okay, so we have 1, 1. Now, how do I know if I'm completely right? Okay, I can actually double check this. Let's just put it into any equation. Let's put it into this one. Does 1 equal, because we said y was 1 and x was 1, didn't we? okay, does 1, which is my y, equal 1 squared plus 3 lots of 1 minus 3. What is 1 squared? We have 1 equals, 1 squared is 1, plus 3, minus 3. They're going to cancel. 1 equals 1. Yes, it is true. Okay. Now, it says it has 1 point. So just make sure you write, therefore, 1 point. Okay, and just write that statement at the end. Nice and simple. Okay, question 10. I love these types of questions because, first of all, if you really aren't sure, you can take a guess. You might as well. Okay, let's just go over a few things. Number 1, quadratics. Any x squares are either like a happy face or a sad face. Number 2, 1 over x. The graph always looks like this. 1 over x squared. If you just learn the shape of these graphs, always looks like this. And a cubic graph looks x cubed, or negative x cubed would look the other way. Let's start from, there we go, something like this, okay? These are terrible drawings. If you want to know more, you can have a look at my A-level chapters. However, positive x cubed is C, negative x cubed is B, and then the x squared we know is D, and 1 over x is A, okay? And actually, you know, some of these questions are nice. You can take a guess if you really want to. Don't ever leave that blank. If you don't write anything, you don't get any marks. If you write something, you have a chance of getting a mark. Okay, question 11, completing the square. So if we have y equals x squared plus 24x plus 137. So remember, we're going to get x plus 12 squared, okay? We're going to minus 12 squared, which is 144, plus 137. So we get x plus 12 squared minus 7 is my answer, okay? So, turning point is, when does this bracket equal 0? This is going to give us our line of symmetry. This is at minus 12, and that is when y equals minus 7. 4 marks, lovely. Okay, these questions are the easiest marks on the paper, as long as you know how to use the calculator properly and you can plot coordinates. So first thing, whenever we're given a table like this to fill in, right, have a look at what it says. It says 5 minus, and wherever it says x, you're going to put brackets, cubed. Okay, and all you're literally going to do is substitute in what's missing. So what happens when x is minus 2? I'm going to put minus 2 here. Now, you need to make sure your calculator has those brackets, because as I've said before, sometimes your calculator doesn't understand. So you should have got 13. Then I'm going to do the same again, but this time inside the bracket, what am I going to put? 0. And I get 5. Going to do the same again, but what am I going to put inside the bracket? 1. I get 4. Do the same again. What am I putting inside the bracket? 2. And then I get minus 3. So this is what I'm getting. Nice and easy. 2 marks. Probably the easiest 2 marks on this paper. Only 2 marks. It's great. But then we get 2 marks again down here. So you all know how to plot the coordinates. It always goes x, y. So minus 2, 13. I go across to minus 2, up to 13. Minus 1, 6. Across to minus 1, up 6. 0, 5. 0, 5. 1, 4. 2, negative 3. There we go. And then what I'm going to do is I'm going to use a pencil. Sharpened. Okay, now whenever we draw curves, we don't want straight lines. We want a nice curve. Now this curve has to go through all of the points that you have plotted. All right, we're going to have a lovely curve. Now, look at that, 2 marks. Okay, I think it's great to practice indices because I think they'll come up all the time. So 9 to the power of 3 times 9 to the power of 5. Bases are the same. We add the powers, we get n to the 8. Okay, now for this one, technically, this is the same as saying c to the power of 3, d to the power of 4, divided by c to the power of 2, d. Now, depending which way you prefer, some of you can cancel this way. Like, I know c cubed, when we divide and they have the same base, we get 3 minus 2, which is 1. So that becomes c to the 1, but that's the same as c. And then 4 minus, if there's nothing with the d, what's technically there? A 1. So 4 minus 1 is 3. So this becomes CD3. Okay? Nice and easy. Then, inequalities. So we've got to solve this. So 5x divided by 2 is greater than 7. What's the first thing I'm going to do? I'm going to divide both sides, multiply both sides by 2. So I get 5x is greater than 14. Now what am I going to do? Divide both sides by 5. So I get x is greater than 14 over 5. Now if I wanted to, I could put that in my calculator or work it out. I get x is greater than 2.8. Either or would give you full marks. Question 14. Okay, mean, median, mode, range. This is combined mean. Now, I love this because for me, I really like how I lay it out. You might not like it, but let's have a look. So there's a total of 45 boys and girls in a choir. The mean age of 18 boys is 16.2. So if we added all the boys together, okay, and how do we find the mean? We add them all up together and we divide by how many there are. How many boys we got? 18. What does this give me? The mean, which is 16.62. So would you agree that the total amount of boys is actually equal to 16.2 times 18? Okay, so that means the total boys is 16.2 times 18. And that's going to give me 291.6. So that is the mean, the total of all the boys' ages together. I can do the same for the girls. If I think the mean of the girls, okay, is 16.7. So I know all of the girls divided by 27 is 16.7. So how am I going to find what all of the girls are? I'm going to do 16.7 multiplied by 27. So 16.7 times 27 is going to give me the total of all of the girls' age. So 450.9. Awesome. Now, if I want the total of all of them, what do I need? I need all of the boys plus all of the girls divided by the total number of boys and girls, which is 45. Do I have all that information? I do. So 219.6 plus 450.9 divided by 45. So plus 219.6 divided by 45 is going to give me their mean years of 14.9. So this is called combined mean. And I like to lay it out like this. It's 3 marks. It's lovely and simple. Right, question 15. Here we go. ADC is a triangle. AED and ABC are straight lines. EB is parallel. Blah, blah. Awesome. Work out the size of the angle EAB. Now, this is 5 marks because we have to give specific reasons. So, step 1. This angle here, how are we going to get this pink angle, Sue? This is, how are we going to get? Technically, this is co-interior angles, yeah? So, co-interior angles add to 180 degrees. So therefore, 180 minus 148 equals 32 degrees. Wow. Are you sure? Is this actually 5 marks? Wait there, because EAB. Then the next one, no way. Angles in a triangle add to 180 degrees, do they not? And this is my triangle, right? So 180 minus 63 minus 32, what do I get? Surely not. 85 degrees. Right, well, let me check this mark scheme. It's 85 degrees. Okay, so you get 1 mark for saying co-interior. You get 1 mark for then working it out. Then you get, that's what we did, EAB. Then you get 1 mark for saying, 1 mark for 85. And then 1 mark for angles in a triangle. Oh, guys, that should say add. Oh my God, add up, not to. Add up to. Wow, that is the nicest 5 mark question I have ever seen in my life. Yeah, that's so lovely. For 5 marks. That's insane. Okay, question 16. Diagram represents a solid cone. The cone has a base diameter of 20 centimeters and a slant height of 25 centimeters. A circle is drawn around the surface of the cone at a slant of 10 centimeters above the base. The curved surface of the cone above the circle is painted grey. Work out the area of the curved surface of the cone that is not painted grey. Give it in terms of pi. Okay, the first thing I like to do with this is what isn't painted grey is the whole cone. Oops. Oh my. The whole cone minus the little top of the cone, isn't it? So then I write down everything that I know. Okay. So what do I know? I know that my radius is 10 here. Okay. And my slant is 25 for the big one. For the small one, technically, if I take away 10, what is my slant? 15. And do I know my radius? No. However, before I move on, I have lengths here. And because we chop it off, technically, these are similar shapes. Okay, you can see how similar shapes are used quite often. So 15 multiplied by my scale factor is 25. So 25 divided by 15 is going to give me a scale factor of 5 over 3. So if my radius is 10, my radius of my small one times 5 over 3 is going to give me the radius of the big one, which is 10. If I multiply by 3 and divide by 5, or divide by 5 over 3, my radius is 6. So I know the radius of the small one is 6. Awesome. Now, for curved surface area, it just wants pi r l. So, here we go. Pi r l minus pi r l. In this case, I have pi lots of 10, lots of 25, minus pi lots of 6, lots of 15. So I'm going to get 250 pi minus 6 times 15, 90 pi, which is going to give me 160 pi. I'm going to leave that in terms of pi. So there we go. Nice and simple. Some people may have done this a slightly different way. You might have worked out the surface area of this and then multiplied it by the scale factor. Okay. And the scale factor squared if you then do surface area. But I like to write these out and draw pictures to help represent it. Okay, question 17. Olivia and Jessica have in total half as many sweets as Fran and Gary. OMG. Right, let's just start this. Olivia and Jessica OJ have Fran, Gary. So they have half as many sweets. So they literally have 50% of their 100%. Do we understand that? It's probably the worst way to write it, but just in my head, okay? Fran and Gary share their sweets in the ratio 2-3. So this is 2-3. Olivia and Jessica share their ratio in the sweets 9-1, yeah? Right, first things first. We need to find a common thing. There's no denominators. We're not doing fractions. Right, we know that this is 10, yeah? And this is 5. Now remember, if this is half of this, what should this be? 20. Yeah, so let's multiply all this by 4 to get, because 5 times 4 is 20, yeah? So now I'm going to get 8, 12, 1, 9. Okay, so that is technically the ratio. Is that right? And then simplest form. Oh my God. Wow, that was easier than we thought. Yeah, that was it. So this is... Whoa. Guys, it's not right. First of all, who does it start with? Fran. Which one was Fran? 8. And then Gary? 12. Olivia? 9. Jessica? 1. Okay, that is it. Sorry. Guys, we should have really listened to which way we got it round, yeah? So because the W was Fran, and we put Fran here, yeah? We'll just make sure you write it the right way round. This is literally the simplest question I've actually seen. Okay, question 18. A, B, and C are 3 spheres. Now, if you know me, you know I like drawings. And there we go. 3 spheres. The volume of sphere A, B, C. So the volume of sphere A is 125 centimeters cubed. So volume is 125, just 125. Volume of B is 27. Okay, guys, I think these are clearly getting smaller. These are not in the order that I drew them, but that's okay. It doesn't matter. You know, the fact that I'm drawing them is a thing. What do I know about spheres? They're all similar shapes, right? Sphere's a sphere. Okay, so I know that, and normally I always go from small to big with this formula. When I'm dealing with similar shapes, I know the volume of the small one, so 27 times the scale factor cubed is going to give me the volume of the big one, isn't it? Okay, so that means the scale factor between them is 125 over 27. How do I then find the scale factor? I have to cube root that. And you're going to find it's going to be nicely, it's going to give you 5 over 3. So the scale factor is 5 over 3 from B to A. I don't know if we needed that. I might have just gone off task here. However, it is what it is right now. We've done it. Right. The ratio of the radius of sphere B to sphere C is 2. Okay. So if I called the ratio of B, the radius of B, let's call that R. What, actually, let's call it X, it'll make your life easier. What would the radius of C be? 2X. So what do we know? Work out the ratio of the surface area of sphere A to the surface area of sphere C. Okay? So, first of all, if the radius of B is X, what is the radius of A? Not X cubed.
I have a probability. Yes.
The radius of B is x, so we needed that scale factor. If we know the radius of B is x, what's the radius of A? What do we do when we do lengths? We multiply by the scale factor. So the radius of A is 5 over 3x. Okay? So now I want us to work out the ratio of the surface area of sphere A to the surface area of sphere C. Well, first let's work out the ratio of the length. Okay, so now what do I have? I have the ratio of A to C. What is A? 5 over 3x. C is 2x, right? We don't care about the x's. So the ratio of A to C is 5, and then if I multiply both sides by 3, it's 5 to 6, yeah? Okay, but this is the ratio of the radius. Okay, it's 5 to 6. I want surface area. What do I do when I'm looking at area? Square. 5 squared is 25 to 6 squared, 36. Okay, why squared? We always do the scale factor squared, or if you wanted to do it a different way, scale factor squared is 25 over 9. Okay, and then that is going to go to your radius, which is 4, and then multiply that up. Okay, either way. The answer is 25 to 36. Go. Okay, guys. So, first step, you're going to expand the first two. Okay, so you're going to get 3x squared plus 2x minus 6x and minus 4. Okay, we're then going to simplify it. Okay, remember we've got the like terms here, and then 2x plus 3. Now, what I like to do to make my life easier, multiply everything by 2x first, and then by minus 3. So I get 6x cubed minus 8x squared minus 8x. Now I'm going to multiply everything by 3. But what I'm going to do is I'm going to write it underneath. So 9x squared minus 12x minus 12. And now I need to simplify it. So I get 6x cubed minus 8x squared plus 9x squared is plus x squared minus 8x minus 12x minus 20x and then minus 12. There's your answer. 3 marks. Okay, so question 20. Diagram shows two shaded shapes, A and B. Shape A is formed by removing a sector of a circle with radius 3x minus 1 from a sector of a circle with radius 5x minus 1. So what that's telling you is this whole thing here is 5x minus 1. So that's the radius of the big one, okay? So technically, what we're doing is the sector of the big one minus the sector of the little one. That's going to give you this shaded area A. We should all be able to, without even knowing anything about sectors, be able to see that. That if we take the small pizza from the big pizza, we're going to be left with that pink shaded bit, aren't we? Okay? Everyone should be able to do this, no matter what level you are, and this could get you a mark. Okay? When we're looking at these questions that are a bit more difficult, we are all about getting the marks. Now, it says the shaded area is equal to the shaded of shape B. We need to calculate the value of x. Okay, so we write down what we know. We know that the radius of the big one is 5x minus 1. And we know that the radius of the smaller sector is 3x minus 1. Okay? Now, area of a sector, what is the formula? The formula is area, pi r squared, everyone knows that. Yeah? Times the proportion of the pizza, which we know is 45 degrees over 360, okay? However, what is our radius here? Oh my God, I can't, wait there. 45 over 360 times pi times 5x minus 1 all squared. Once I work that out, I'm going to minus 45 over 360 multiplied by pi multiplied by 3x minus 1 all squared. Even writing this down, you're going to get a mark and all we've done here is written what we're going to do. Okay, we're breaking it down, right? So now is where the fun starts. We are going to start to expand, simplify, etc. First thing I'm going to do is I'm going to check what 45 divided by 360 is. I get 1 over 8. Okay, so this is essentially, oh my God, what has happened there? This is essentially pi over 8. Is everyone happy that 1 over 8 multiplied by pi is pi over 8? Next, we have this bracket. 5x minus 1 squared is the same as 5x minus 1, 5x minus 1. We should all be getting accustomed now to multiplying these brackets. Everyone can multiply a double bracket. Even if you did this, you might have got a mark. I don't know the mark scheme yet, but so what are we going to get? 25x squared minus 5x minus 5x. So that's minus 10x. Yeah, I've done it in one. We should be all right with that. And then minus 1 times minus 1 plus 1. Awesome. And all of this is multiplied by pi over 8, technically. Right, then we're going to minus pi over 8. Lots of. So again, with the 3x minus 1, 3x minus 1, we should be happy to get 9x squared minus 6x plus 1. Again, if I've done that too quick, just slow down. We should be at that stage where we can expand these. Now, because pi over 8 is common in both, essentially, I can keep my pi over 8 on the outside. We could multiply everything by pi over 8 if we wanted, but we know pi over 8 is a term of everything, right? So just factor out that completely. And then I'm going to start. This is going to give me 25x squared minus 10x plus 1. Now, watch out for this. This is where people go wrong. Minus 9x squared. Then I'm going to have minus 6x. So what's that? Plus 6x. This is where the biggest mistakes are made. Then I'm going to get minus plus 1, which is minus 1. So then this gives me pi over 8, bracket, 25 squared minus 9x squared, 16x squared, minus 10x plus 6x, yeah? Minus 10x plus 6x, minus 4x, plus 1 minus 1, gone. What else can I take out of here? What does 16 and 4 have in common? 4. So actually, guys, I could take out 4 pi. I could take out 4, right? And I get 4x squared minus x. Yeah? What does 4 over 8 equal? I think this is a non-calculated question. Isn't it beautiful? I'm going to get pi over 2. X, bracket, 2x minus... No, that's a lie. That's a lie. If I factor out an x... Wait there, guys. I'm going to slow it down. Right. I'm going to multiply everything by... I'm going to simplify now, just to make my life a bit easier. Okay. 4 over pi times 4x squared is 2 pi x squared. Then 4 pi over 8, which is a half pi, times this is negative pi over 2x. Okay? However, I need to solve this, so I'm going to factorize it again. I just confused myself. Right, so what do they have in common? A pi and an x. Okay? So then I'm going to get 2x minus a half. Okay, so now I need to solve for x. What does this equal? This equals the area of the circle. Jesus. Here we go. So this equals the area of the circle. How do I find the area of a circle? Yeah, pi r squared. If my diameter they've given us is 2 minus 2x, what's my radius? 1 minus 1x. Or otherwise known as x. Okay, so let's do that over here because we need this for the next part. So pi lots of 1 minus x squared. Remember, this is 1 minus x, 1 minus x, and I get pi here, right? So let's expand. So I'm going to get pi lots of 1 minus 2x plus x squared, okay? So 1 times 1, 1 times minus x times 1, minus x times x. All right? So then, right, so these two equal each other. Do you know what, guys? I'm going to keep this as all the pi's here, all right? I'm going to go back to this one, the expanded one. So this is 2 pi x squared minus pi over 2x equals, and then I'm going to multiply everything by pi here. So I'm going to get pi minus 2x pi plus pi x squared. Now, just like, you know, when we did those hard volume and surface area, every single term has a pi in, right? So we can divide every single term by pi. Now, I didn't really need to expand that, but I want to show you the understanding. We can't do it if only some of them have got a pi in. Every single term here has a pi in, right? So I'm going to get 2x squared minus a half x equals 1 minus 2x plus x squared. I'm going to move everything to the left-hand side because I can see a quadratic here. So, guys, if I'm minus x squared from both sides, plus 2x to both sides, minus 1. 2x squared minus x squared, what do we get? X squared. Minus a half x plus 2x. What do we get? Yes, 1.5x or 3 over 2x. And then minus 1 equals 0. If I want to make my life easier, even though fractions are our friends, what could I do? I could multiply everything by 2. If I multiplied everything by 2, I'm going to get 2x squared plus 3x minus 2 equals 0. Okay? Now, you can factorize this, use the quadratic formula, whatever you want, use your calculator, okay? You just have to be able to get to this stage. So, if we factorize this, we're going to get 2x minus 1 and x plus 2 equals 0. So that means x equals a half or x equals negative 2. Now, guys, tell me, can x equal negative 2? No. Why? Because we're talking about length, so we're going to reject this. Okay, so x equals a half. Has it asked us to find x? It has. We have done. It's not too much for 5 marks. We just went through it really slow. Like, if I was going to do this on my own, it would take me 3 minutes, I reckon. Okay? So this, though, is all that explaining. Like, I would have missed out a few steps, you know, of my working out. And this is about, though, it's about writing down what you know, writing down what you need, writing down any formulas, substituting, and then it's all about algebraic manipulation. Okay, here we have inequalities on a number line. So first of all, if it's coloured in or not coloured in. If it's not coloured in, it's less than or equal to. If it is coloured in, it's less than or greater than. If it is coloured in, it's less than or equal to or greater than or equal to. Here we can see that our number is bigger than minus 1. So our number, we could say x, is bigger than minus 1. And it's not bigger than or equal to because our circle is not coloured in. Now here, minus 3 is less than or equal to y. So that means where minus 3 is, it's a solid circle. And it's just less than 4. So I just have a normal circle and I can draw my number line. Okay, so this is a lovely equation. And what we're going to do is instead of writing x squared, I'm going to write bracket squared minus 2 brackets, sort of 2x plus 2. I'm going to put that into my calculator. And then in my bracket, the first one I'm going to insert is minus 1. Now, the reason why I use brackets is because, as I've explained, sometimes the calculator messes it up and doesn't understand that minus 1 squared is actually a positive number, because we know that all square numbers are positive. So when I put this into my calculator, I get 5. When I put 1 in, I'm going to get a different number because we're no longer doing the negative times positive. So I get 1. Then I'm going to go back into my calculator and press 2. I get 2. And then I'm going to go back in and press 4. And I'm going to get 10. So with those now, all I need to do is plot it. And these are such easy questions, okay? So minus 2, 10. Also, make sure you use a pencil. Minus 1, 5, 0, 2, 1, 1, 2, 2, 3, 5, and 4, 10. Okay, and then now what you want to do is you want to connect the dots using a nice curve that goes through all the points. Obviously, using a pencil would be the best approach. Okay, there you go. Nice and simple. That is literally giving you 4 marks for that. Now, for the next part of the question, I've seen some hard ones of these. I've seen some easy ones of these, and I think this one's relatively simple. So here, for example, we have x squared minus 2x plus 2. We can see this is x squared minus 2x plus 2. Awesome. But here it equals y. Here it equals 4. So that means our y equals 4. Where is y equals 4? Well, y equals 4 is here. So anywhere on this line is where y equals 4. So when we're finding the solutions, this is a simultaneous equations, but using the graph. We're going to see where does it cross, and we're going to go down, and we're going to find the solutions of where it crosses. And this is going to be my x coordinates. So I can see here I've got minus 0.8 roughly for one of my x's, or x equals, this is like 3 point, I don't know, is it 3.1? No, sorry, that's 2.5. I get like 2.6-ish. Okay. Now, in the mark scheme, it gives us a range of minus 0.65 to minus 0.8 and 2.65 to 2.8. However, you can see that when I have drawn my dots, I've used a highlighter to show you. If I didn't use a highlighter, I would be more exact, because maybe like from here to here, it would actually cross at this bit. Can you see? So just make sure you do your best, because there is a leeway here. Okay, awesome. Okay, surds. So you can see here we have to rationalize the denominator somehow, and expand, simplify, etc. So remember, with any fraction, if we want to manipulate it, we've got to multiply it by the same thing over the same thing, because that's a whole one. We're not changing the quantity. I've got a lovely video on surds if you want to watch it. I would highly recommend it. Okay, so we're going to multiply this by root 5 plus 5 and 5 root 5 plus 5, okay, because this is going to give me completed the square, not difference of 2 square form, which means I get a square number on the denominator, so I'm not going to have a surd. Okay, so we can literally rewrite this again using our brackets so that we make sure that we get this correct. Okay, some people like to do this because when they expand 2 brackets, it'll make it easy for them. Okay, so root 180 times 5 root 5. Now it's show that. So I think what we should do first is, because when I put this into my calculator, it gives me 150, which is essentially cheating. Okay, because it wants you to show. So what is root 180? So root 180, okay, let's just put that into your calculator. If you put root 180 in, you're going to get 6 root 5. You can simplify it to that. How do we get that, though? And that is because root 80 is 36 times 5. Remember, you have to have understanding of surds, not just use your calculator. Okay, and root 36 times root 5 is the same as 6 root 5. So actually here, I'm going to have 6 root 5. Now, we can see on the numerator that 6 root 5 minus 2 root 5, this becomes 4 root 5 bracket 5 root 5 plus 5 all over. And then now we can square this because 5 root 5 times 5 root 5, that is going to give me 125. Okay, where did this 2 come from? Sorry, guys. And then minus 5 times plus 5 is minus 25. Now, there is no need for me to do minus 5 times 5 root 5 and then 5 root 5 times positive 5 because essentially they'll cancel. So now I'm going to have 4 root 5 times 5 root 5. Okay, that's going to give me 4 times 5 is 20, times 5 is 100. Again, you can put that into your calculator. 4 root 5 times 5 is 20 root 5, all over 125 minus 25 is 100. Now, we can't leave it there because it wants it in this form, so I have to split it up. So I've got 100 over 100 plus 20 root 5 over 100. So now I need to simplify it. This is a whole one. And then 20 over 100 is actually 1 over 5. So this becomes plus root 5 over 5. 4 marks, okay? Nice and easy. Right, question 24. We haven't seen any trig yet, really, so we need to do this. Step 1, label your triangle. It's right angle, so opposite, hypotenuse, adjacent. Okay, so, ka, toa. Right, what do we have? We have O, we have H. Okay, we have H, we want O. O and H, sine. So sine of the angle equals opposite over hypotenuse. So sine of 34 equals our opposite, which is x, over 178. So I'm going to do sine of 34 multiplied by 178. This is what x is going to give me. Okay, I'm going to put that into my calculator. So sine 34 times 178. I'm going to get 99.53. It wants one decimal place, so it's 99.5 degrees. Okay, guys, fair warning here. This is the hardest proof question I think I've ever seen in the GCSE. Normally, they ask you questions like prove that three consecutive even numbers is divisible by whatever, okay? And in that case, you know the first one is 2n, the next one is 2n plus 1, plus 2, the next one is 2n plus 4. However, if we're talking about odd numbers, you can have 2n minus 1, yeah, 2n plus 1, 2n minus 3, etc. So normally we get those types, or we've got to prove by showing. This one's slightly different, and this involves your understanding of trigonometry, particularly the sine rule. So to make our lives easier, I'm going to do AB, AC, DC, BD. Okay, just so that when we're looking at them, we can see really what's going on. Now, I always think it's better to draw them out because let's just, so B, D, A, and this is X, right? And then we have again D, C, A, and again this is X. Okay. So we've got lengths and angles, haven't we? Right? So what do we need to do? We need to sort something out. What do we know? There's not right angles, so I've got sine or cosine rule. Okay, what do I know? I know sine of A over A equals sine of B over B. Okay, let's use this with what we've got. So let's start with this one here. So sine of our angle X, okay, is opposite what? BD. Lovely. And this equals, we want AB, so this is AB. I don't know what this angle is, so I'll tell you what, I'm just going to call this angle Y. This equals sine of Y. Also, there's not really a lot I can do here. Right, next one. Opposite, what do I have? I have sine of X over DC equals AC. Now, this is this angle here. I could use a different letter, call this Z, but actually, guess what we've just spotted? That this is on a straight line. So this essentially, this is going to be 180 minus Y. So this is sine of 180 minus Y. Okay. Now, before we go any further, I actually want to, because I mean, you could do this one or two ways, but first of all, sine of Y equals sine of 180 minus Y. You have to state this fact, and this is true. Why? Think about it this way. Sine of 30 is a half, right? What is sine of 180 minus 30? That is sine of 150, which is also a half. Okay, and this is because of the symmetry in the sine graph. Okay, we're saying here, these two values, if this is Y, this is 180 minus Y. Okay, so this is a fact that you need to know. Again, guys, this is a total grade 9 question. So actually, I could rewrite this as, instead of sine 180 minus Y, this is still sine Y. Now, what I have here is variables on both equations that I could actually manipulate. So I could divide both sides. I can do cross multiplication here. So I've got sine over x over sine y equals BD over AB. And here, cross multiplication, I get sine over x over sine of y equals DC over AC. Awesome. I can put these equal to each other because this equals this. So BD over AB equals DC over AC. Now, unfortunately, that's not what they want, but we can again technically cross multiply the whole thing again. So D is exactly the same as AC over DC equals AB over BD, because you can see here it's just been flipped. So we could do like cross multiplication. Therefore, proved. Wow, that was a difficult 4-mark question if you didn't know where you were going with that. Okay, arithmetic sequences. So the fourth term is 3, and the sum of the first 6 terms is 27. 6 marks. Wow, this is easy. Now, we can use this doing 2 ways. One that I like to call common sense. So if I know 1, 2, 3, 4 is 4. Sorry, the fourth term is 3. And then 5, 6. I know they all add to 27. Okay, so UN is the form you need to remember. UN equals A plus N minus 1D. So I know that 3 is the fourth term. So that's A plus 4 minus 1, lots of D. So 3 equals A plus 3D. Now the other formula is given to you. That's the sum formula. Sn equals N over 2. 2A plus N minus 1, lots of the difference. Okay, so it's the first 6 terms. This is S6 equals 27. So technically, 27 equals 6 over 2. I'm just following the formula. 2A, we don't know what A is. 6 minus 1, D. So I get 27 equals 6 divided by 2 is 3. 2A, 6 minus 1 is 5, D. Okay, again, guys, we're talking grade 8, grade 9 questions here. So if you're not following, it's okay. Just skip this one or do your best. And if you want to learn it, I do have videos on this, so you have time as well. Okay, here I have a pair of simultaneous equations. I'm going to rearrange this one here to get 3 minus 3D equals A. So now I'm going to substitute that in. 27 equals 6 lots of 3 minus 3D plus 15D. So then I get 27, expand the single brackets, 18 minus 18D plus 15D. Now I'm going to take away 18 from both sides to get 9, and then minus 18D plus 15D is in fact minus 3D. That means my difference is minus 3. Okay, so if my difference is minus 3, each time I'm minusing 3. So this becomes 0, this becomes minus 3. So that means on this way I'm adding 3. So that's 6. Oh my god. And it becomes 9. And then becomes 12. So we can check. What is 12 plus 9? 21. 27, 30, 30, 27. So it does actually give me 27 when I add them up. So my first letter is A equals 12. Now, if I didn't want to use the common sense way, where I just went backwards here, I could substitute minus 3 into here again and then rearrange it. Okay, so the last one is also, given that the sum of the first 9 terms is 54, show this. So you know that n is 9, so you're going to get 54 equals n over 2 brackets 2a plus 9 minus 1 lots of d. Okay, you'd rearrange this and you would end up with this. Okay, nice and simple. It was the part B that I really wanted to focus on. Given that the 8th term is half of the 7th term, so what does that mean? So that means that the 8th terms, for example, 1, 2, 3, 4, 5, 6, 7. Okay, if the 8th term, 1, 2, 3, 4, 5, 6, 7, sorry, 8. If the 8th term is half of the 7th term, let's say this is x, this becomes a half x. Okay, this is where we need to use some of our, knowledge. So what does that mean? Here we're just talking terms. So again, un equals a plus n minus 1 d. So in this case, we're saying u7. Okay, so a plus 7 minus 1d. So we're going to get a plus 6d. So essentially, x is a plus 6d. Okay? But what do we know? That u8 is a plus n minus 1, 7d. So we know that the 7th term equals half of the 8th term. Okay, and this is how we then get this formula. We can rearrange and multiply. So we're going to get 2a plus 12d equals a plus 7d. We're going to get a plus 5d equals 0. So now that we have this, and we have the one from before, it's back to simultaneous equations, okay? And then you're going to get your difference is minus 1.5 and your a is 12. Okay, just wanted to let you know a problem solving style one, because question 26 was a bit easy. However, it just gives some people the skills. Good luck for your exam. Remember, these are predicted high-frequency topics that have not appeared in paper 1HR yet. Okay, the regional one. So good luck. Well done.